Hi students, today we are going to discuss a new chapter. So before going to discuss that, I would like to explain some of the incidents happened in the class yesterday. So yesterday I asked my students come to my home in the evening session at 7 p.m. to attend a party on behalf of my son's birthday. So I said you all must come. Some of the students asked me, where is your house, sir? Where is your house? I said it is 1 kilometer from our school. I said that it is 1 kilometer from our school. They said okay, sir. But surprisingly, no student has attended to the party in the evening. So next day morning I asked in the class, why you did not come to party? The total class is silent. Again I asked with increasing volume, why you did not come to party? One student asked, sir, you said your house is 1 kilometer from our school, but you did which way we should come. That means in which direction we should come from the school, you did not say. I understood. And I asked another question. If you go to the market to purchase some vegetables, what do you ask the vegetable vendor? So if you want to purchase a tomato or potato, what do you ask? A student said that, give me 1 kg tomato or 1 kg potato. Right? So 1 kg. Then I asked, will he give 1 kg or will he ask in which direction here also? No, sir, they'll give simply 1 kg. Right. So I would like to ask another question. Now the class of our door is half opened. It is half opened. Means it is not fully closed, not fully opened. It is half opened. If I apply force on the door, will it open or close? Tell me. Okay. If I apply a force, some 10 Newton force I am applying, will it open or close? Tell me. Some of the students said it will open. Some of the students told that it will close. But very few students told that we cannot say, sir. We cannot say. Why can't you say? I asked again. So they said that you are applying 10 Newton force, but you are not given here in which direction you are applying. Is it a pull or push? You did not say. Very good, I understood. Now a student surprisingly said that, sir, by listening all these I understood something. Shall I tell? He asked. Yeah, obviously. So he said that, sir, some physical quantities require, along with the magnitude, direction also. But some physical quantities require only magnitude. I surprised and I clapped for him. Yes, what I want to exactly convey that is that. So here in physics we have many physical quantities. We have many physical quantities. What is physical quantity? We learned what is physical quantity, different types of physical quantities in measurement lesson. Right? So we have many physical quantities in physics. These all physical quantities are classified into two groups. Like a class. In our class there are students. Yes or no? These students are classified into boys and girls. Right. Similarly here also in physics there are many physical quantities. These all physical quantities are classified into two groups. One is scalar physical quantity. Another one is vector physical quantity. One is scalar, another one is vector physical quantity. On what based they have divided, sir? These are divided based on their geometrical representation, sir. Remember this point. Geometrical representation. What is geometrical representation? We shall learn later. Now, all the physical quantities are classified into two. One is scalar and another one is vector. Here, what is scalar? What is vector? Let us see quickly. So, scalar are the physical quantities. Scalars are the physical quantities which has only magnitude. Only magnitude. Those physical quantities we are calling as scalar physical quantities. Means some physical quantities require only magnitude for its complete representation. Okay, no need to give its direction. So just like mass of tomatoes or potatoes is 1 kg. It's enough. It gives complete representation of its. Yes. So similarly here, if I see force, okay, so along with the magnitude I should give some other information. What is that information? Along in which direction I am applying force depends on that. So that scalars are the physical quantities which has only magnitude. Those are called scalars. Coming to vectors, vectors are the physical quantities which has magnitude, direction, and obeys laws of vector addition. Obeys laws of vector addition. This kind of physical quantities we are calling as vector physical quantities. Once again, see the definition of vector. The physical quantity which has magnitude, direction, and obeys laws of vector addition are called vector physical quantities. What is the definition of scalar? The physical quantities which has only magnitude are scalar physical quantities. Right. Here, what is laws of vector addition? We shall learn in further classes. Just to remember that definition, that it has magnitude and direction and obeys this one. Now, let us see some examples of scalar physical quantities. Okay. So, the scalar physical quantities are mass, length, time. These all you learnt in measurement lesson. Yes. Okay. Temperature, speed, work, area, volume, etc. Many are there, sir. So these are all we are calling as scalar physical quantities. Why we are calling them as scalar physical quantities? Very good. They have only magnitude for its complete representation. Coming to vectors, what are the examples of vectors? Okay, so first one I would like to tell is force. It's a vector quantity. And velocity. Okay, and acceleration. Okay, next momentum, impulse, etc. Many physical quantities are there. Okay, so in this way we are broadly dividing based on their geometrical behavior all the physical quantities into scalars and vectors. Other than scalars and vectors, there are very few quantities. They are called tensors. They are called tensors. Remember this word. You will come across this tensors in your higher classes. Okay, so this is in this what we learn. We learn definition of scalar, definition of vector, examples of vectors and examples of scalars, and why and on what basis these are divided. Okay, now let us see the mathematical definition of vectors. Mathematical definition of vectors. Mathematically, vectors is a vector is defined as a directed line segment. A directed line segment. What is this directed line segment? I would like to explain to you. First, let us see what is a line. What is a line? So you know in mathematics what is a line. Line is a straight and there are no bends, has no thickness and extends in both the directions without ends till infinite. Yes or no? So just this is a line. It has no ending points. It will be extending up to infinite distance and has no thickness. Coming to this, does it have any magnitude? Any magnitude? No, because it is extends up to infinite, right? Does it has any direction? No, it has no particular direction. Yes, so this is a line. Now coming to another one, ray. What is ray? A ray is a part of line with a starting point but has no ending point. See, this is the ray which has a starting point. Let us take A is the starting point and there is no ending point. It moves up to infinite distance, right? This is called a ray. What about its magnitude? Does it have any magnitude? As it is moving to infinite distance, there is no magnitude. But what about direction? It has a particular direction. It is moving in a direction. Let us take this as east. So it has a direction, right? Can I call this as a vector? No, because it has a direction only, but there is no magnitude, right? Now next one is a line segment. What is that? Line segment. So what is line segment? If you take a line, okay, so a line segment is a point of line that is bounded by two distinct end points. Two distinct end points. This is A and this is B. So this is called AB is called a line segment. In the total line, it is a line segment. AB is a line segment. It has end points. Okay, that means does it have any magnitude? Yes, it has a fixed magnitude. It can be 1 centimeter or 2 centimeter or whatever it may be. What about direction? It has any direction? No. The answer is no. Next, let us see what is meant by directed line segment. What is meant by directed line segment? Directed line segment. See this. So directed line segment is nothing but, see, this is a line. AB is a line segment. Now we are giving direction to this just by keeping an arrow. So now the point AB is a line segments, end points of the line segments, and this denotes the direction. It is written as AB bar. So that, does it has any magnitude? Yes, it has magnitude. Okay, A to B. And does it provide any direction? Yes, direction also has. It is from A to B. From A to B. Now see that it has magnitude and direction, so that a directed line segment is taken as a vector in the mathematics. So the direction of the vector is from A to B. If I keep arrow in this way, what does it mean? It can be written as BA. This is from B to A. Remember this. So in this way, mathematically a vector can be defined. Clear? Right. So far we learnt about scalar vector definition and examples we have seen. So now let us discuss about representation of scalar and vector. Representation of scalar and vector. So how we represent a scalar and a vector, let us see here. So scalar is denoted by or represented by a letter, simply a letter. Scalar simply represented by a letter. What is letter here? Any alphabet. Suppose let us take mass of an object. Mass is a scalar. Simply it is denoted by m. So it is represented by letter m. So m, just I have written m. So it is a symbol of a scalar, right? So let us take time. Time is represented by t, that's it. Let us take temperature. It is denoted by theta. Okay, let us take speed. It is denoted by v. And this way we represent scalar quantities. How we represent vector quantities, let us see. Right? Vector quantities are represented by a letter. On the head of the letter we write an arrow. An arrow on the head of the alphabet. Head of the alphabet. Suppose let us take a force. Force is a vector quantity. How to represent it? Just you write its alphabet. F is denoted by F, and on the head just I am drawing an arrow, right? So similarly, velocity is a vector physical quantity. So velocity symbol is v. So as it is a vector quantity, just you draw an arrow on it. The arrow on the head of the alphabet represents the symbol of vector. It is a symbol of vector. It's not gives the direction of the vector. Remember this point now. The arrow on the head of the alphabet gives the symbol of the vector. It doesn't give direction. It doesn't show the direction of the vector physical quantity. In this way we represent scalars and vectors. In some textbooks the vectors are denoted by bold letters. Instead of writing arrow on the head, they will be giving bold letters. Bold letters means thick will be there. F, velocity, V. Okay, in this way. Acceleration A. Acceleration A. In this way, the bold letters they will be denoted. Okay, so this is the representation of vector and scalar simply. Next, let us see how vectors are represented geometrically. So that we are calling as a geometrical representation of vector. Geometrical representation of a vector. Let us see how geometrically a vector is represented. So for example, for this I take a vector quantity force. I am applying 10 Newton force on an object in the direction east. Let us see that. I apply 10 Newton force on an object in the direction east. Here 10 is what? We know that it is the magnitude. What is east? It is the direction. Then how to represent it geometrically? So very easy. So before going to represent this, let us draw the directions on the paper. How we will draw directions on the paper? So this will be taking as east, and this is west direction. This is the up is north, and this is the south. In this way we represent directions on the paper. So east, west, north, south. Now I should draw a vector. Right, geometrically I should draw a vector that should point towards east, and its magnitude should be 10 Newton. So here, see, this is, you choose any point. I am choosing this point as a starting point of the vector, and it is towards east. Towards east. This is my force vector, which is equal to 10 Newtons east. Okay, so here the arrow of the vector represents the direction. Okay, what about the magnitude? The length of the vector here to here gives the magnitude. I am writing here, see, length of the vector gives magnitude. Length of the vector gives magnitude. Arrow gives the direction. Understood? So the length of the vector is magnitude, and the arrow represents direction of the vector. Here if it is 10 Newton, I have drawn this magnitude. If it is 20 Newton west, for example, let me draw force is 20 Newton north, or let us take any direction. I am taking north here. So here 20 Newton I should draw first. So I have taken this much length is 10 Newton. Then 20 means it should be double. Okay, and the direction is north. Then the arrow is up. In this way, one can represent vectors geometrically. Understood? So if it is northeast means you should draw in this direction. Northwest, southwest, southeast. These are the directions. So northeast, northwest, southwest, southeast. These are the directions. Okay, so in this manner one can represent vectors in a geometrical. Now I would like to ask you a question. So the question is, which of the following is a vector? Which of the following is a vector? You should identify vector. So options A is 20 meters, B is 15 kg, C is 2 Newton east, and D is 1 liter. 1 liter. So now see that which is vector. Obviously C is vector. Why not A, B, C? Suppose you see A. For A it has only magnitude, there is no direction. Coming to B it has only magnitude, there is no direction. Coming to D also it has only magnitude, there is no direction. But in case of C it has magnitude as well as direction, so that it is a vector quantity. In this way one can identify which is vector and which is a scalar. Sometimes the question will be asked like this. For example, A is a vector. It is 20 meter in magnitude, and its direction is given that 60 degrees south of east is given. Okay, 20 meters magnitude, 60 degrees south of east. So how to draw this vector geometrically? How to represent this vector geometrically? Let us see. So we have seen already how to draw directions. So this is east and west, north, south. So from the origin, means from this point we are going to represent the vector. So its length is 20 meters. I should draw the vector length, means magnitude of the length of the vector should be equal to 20 meters. And the angle is 60 degrees south of east. South of east means this portion will come. This is the southeast. Then the 60 degrees angle made by the vector with the east or with the south, which we should take. Understood? So here 60 degrees is given. The 60 degrees angle made by the vector with the east or south. Right? Here I will give simple idea to how to identify that. So the end one, you see that which is the end direction, that is east. That means the vector makes an angle 60 degrees with east. Understood? So that means I am drawing that vector, this is, and it makes an angle 60 degrees here. This is called as 60 degrees south of east. Okay, south of east. Then the length of the vector gives the magnitude. So how much it is? 20. In this way one can geometrically represent the given vector. Okay. This is today's class. So we learned in this definition of scalar and vector, and the examples and how to represent a scalar and vector, geometrical representation of vectors. These are all the things we discussed today. So on this lesson, I would like to upload a worksheet for your practice purpose. I have uploaded the worksheet in the description of the video. Just go to description and click that link so that you can download the video from that. Enjoy that. Before that, you subscribe my channel so that whenever I upload a new video, you will be notified that. Share it and like it. Thank you very much.